Video's a little late. Sorry about that. I had some crazy stuff happen at the house that kept me doing this. So this is domain and range exercise 2. This is a new version of what we originally had. So the easiest way to do this, like I believe I said in the note description, we're gonna go to Desmos, graphing calculator, and just type in our equation. We can easily see from last week, domain never stops going to the right, never stops going to the left. It's going to be all real numbers, never stops going up, and never stops going down, all real numbers. The other way to do this, so the exponent here is a 1. Whenever your exponent on the x is odd, the domain and range is going to be all real numbers. And we'll see that if we go down here, look at x to the third power. It has a little curve in the middle, but it still goes all the way up and all the way down. For all the normal functions that we've covered so far, except for, so functions, if the equation is a function, which means the exponent of y is 1 and x is not equal to a number, the domain is going to be all real numbers. So for the most part, we're only looking at what the range is going to be. So the range for our odd functions, the ones with odd x exponents, the range is going to be all real numbers. So what do we do when it's even or when it's absolute value? For the most part, we can look at this last piece. That's going to tell us what number we're going to have in our inequality. So here, what number is there? It's actually going to be a plus 0. So we make our inequality for our range. We're going to have 0 on this side. When it's an even number up top, it's going to face up, which means it's facing up. When it faces up, we're going to use the greater than or equal to symbol, and we always put y. So that is the range is an inequality. I assume you know how to make it an interval notation based off of what we did last week. If not, you can contact me. So now if we look at this one, what do we have here? We have a plus 0, and we have this negative sign. This means it's going to face down. So when we put the equation, negative value of x plus 1, the absolute value bar is going to be on top of the backslash. It's a vertical bar. So we see now that has this negative, so it's facing down. If we get rid of the negative, it'll be facing up. So when you have our negative, it's facing down. And we put this symbol. Instead of being greater than, it's going to be less than. And what number do we have? 0. Here's the y. So
I had no idea how.
This is a giant jump cut. I know. I apologize. It's been about 2 hours since last time I was here. I'm just going to start from the top and explain what I wrote down. If we look at number 1, the exponent of x is an odd number. That means our domain and range is going to be all real numbers. That'll be true for 3 and 5 as well. On number 2 and number 4, we see that the exponent is even, or we have these absolute values. It means the same thing. So if you look at here, functions with an even x exponent, the range is either going to be y is greater than or equal to a number, or it's y is less than or equal to a number. Y is going to be less than or equal when there's a negative in front. And greater than or equal to when there's no negative in front. So looking at that information, you can solve most of these without needing to ever put in your calculator. But you always can. Here on number 11, x equals 5, we know that's a vertical line. So we know the range of that's going to be all real numbers because it goes up and down. The domain, when you just have a number, interval notation requires there to be two numbers. So we're going to put the same number twice because it goes from 5 to 5, and the brackets means equal to. And that's for the domain. For this one, you'll need to solve for y, as in get y by itself, and then put in your calculator. So here's the real tricky ones, these fractions. Remember for this, its domain will not be all real numbers because we have 1 divided by x stuff. So what we're going to do, we cannot divide by 0, so we're going to set the bottom not equal to 0. So in our example, we're going to have the function 1 over negative 3x minus 8. So to find our domain, I'll start this over. So you can see all the steps. You notice we set this not equal to 0 because that's what was on bottom. So the first step of getting this by itself is to move the 18. So we have negative 3x does not equal 18 divided by negative 3. Divided by negative 3, we have x does not equal 18 divided by 3, negative 6. And that's the domain, for example. So if we go up here, our bottom does not equal 0. And that's the whole thing. We solved it. And on this one, we have 3x minus 9 does not equal 0. I have this set up. I'll leave that up to you to solve. So that is exercise 2. If you have any questions, please let me know. Kyle folks out. Peace.